In this video, we will determine the molecular geometry, hybridization of the central atom, and whether the molecule is polar or not in carbon dioxide, sulfur tetrafluoride, and xenon difluoride. So we'll first do carbon dioxide. So to find the molecular geometry, we'll first draw the Lewis dot diagram. But to do this, we need to first count the number of valence electrons. So carbon has 4 valence electrons, and oxygen has 6, and we have 2 of them. So we'll add 6 twice to get a total of 16 valence electrons. So to draw the Lewis dot structure, we'll first our central atom, and then add the oxygens, and then we'll add the electrons. So that's 16 electrons, but we need to follow the octet rule, so we need to form some double bonds. So we'll get this, and as you can see, carbon has 8 electrons surrounding it. Each oxygen also has 8 surrounding it. So now the molecular geometry is linear because there's 2 bonding domains and 0 non-bonding domains. And also from this, we see that there's a total of 2 electron domains, meaning that it has a the central atom has a hybridization of sp. And so from here we can now see if it's polar or not. So we'll see that the oxygen bonded to the carbon, the polarities of this bond is canceled out by this bond. So overall, the whole molecule is nonpolar. So next, we're doing sulfur tetrafluoride. So now, once again, we need to draw a Lewis dot diagram. So we need to add the number of valence electrons. So we'll do sulfur has 6, and add 7 4 times because fluorine has 7. Get a total of 34. So now we'll draw it. So we have our central atom, now our 4 fluorines, and we'll add electrons to them. So here we go. And that's 32, but 32 electrons, so we're still missing 2. But because sulfur is below period 2, it can break the octet rule, so we can add 2 electrons up there. So from this, we see there's 4 bonding domains and 1 non-bonding domain, which gives it the seesaw molecular geometry. And also from this, we see that it has 5 electron domains, meaning that it has a hybridization of sp3d. Also from the structure, we can see that the molecule overall is polar, because we'll see these 2 bonds are on the axial positions, so they'll cancel out each other, while these are on the equatorial axis, and we'll see that this lone pair can't cancel out the polarities from these 2 bonds. So overall, the molecule is polar. And the last one we'll do is xenon difluoride. So count the number of valence electrons. So 8 plus 7 plus 7 is equal to 22. So we draw our central atom. Okay. Now we draw the electrons on the fluorine. And xenon is below the second period, so it can also break the octet rule. we get our Lewis dot structure like this. So in here we see it has the central atom has 2 bonding domains and 3 non-bonding domains. So this gives the molecule a linear molecular geometry. And in total, around the central atom, we have 5 electron domains, giving the central atom sp3d hybridization. And we'll also see that the molecule is nonpolar because these 2 bonds are on the axial positions, so they'll cancel each other, while these 3 lone pairs are in equatorial positions. They also cancel out each other. So overall, the molecule is nonpolar.